All right, this is Module 1, Lesson 14. We're going to talk about computing scale factors. All right, so we did this already a couple lessons ago, but we're going to just practice again by finding more scale factors. So before we begin this lesson, we have to go over changing units in the metric system. You're going to need to know how to do this. So this is the units in the metric system: kilo, hecto, deci, all the units, meters, liters, grams. I'm sorry, that's deca. This is deci. Centi and milli is going to be all of the prefixes. So if you want to just label, this is meters, liters, and grams. That's your units. Okay, this is kilo. This is hecto. This is deca, deci, centi, and milli. So if you ever see these prefixes, this is where you're going. Now, the way this works is you have a starting point, whatever the problem tells you. So in this example, for meters, we're starting at meters, and we're going to centimeters. So if you look, you go over 2 spots to the right. That's the same thing you're going to do with this. So 4 has a decimal place that starts at the end. You move over 2 spots, which would be 400 centimeters. So we're just going to practice converting like this. So 80 has the decimal point at the end. We're starting at millimeters and going to centimeters, which would mean you're going 1 spot to the left, which would be 8. Okay, start at meters. 50 has the decimal point at the end, and we're going to millimeters. So 1, 2, 3 spots to the right, which would be 50,000. All right, now this time we're going from centi to milli, which is over 1 spot. So it starts at the end, move over 1 spot, which would be 2,000. So that's just a practice of how to convert in the metric system. Now, let's actually go to our examples. Example 1. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 by 75 feet on the school property. Will the lot be big enough for the court he planned? Okay, so let's just talk about what scale is being used. Yesterday we talked about scales. Now, if you look up at the top, it usually gives you the scale. Sometimes we'll have to change it so that it begins with a 1. This one actually says that 1 inch is 15 feet. This actually is your scale. We don't have to do anything with it because it starts with a 1. Now, scale factor is different. Scale factor is telling you how many times larger or smaller. So to find the scale factor, just remember that both dimensions need to be in the same unit. So, all right, let's start with scale factor is the same thing as unit rate. Well, how do we find a unit rate? We find it by doing y divided by x. Now, in the lesson before, I told you that your drawing is always your y. That's your new value. And your original or your actual is always your x. I always like to write this just to remind myself that. Now we're going to take this scale and we're going to enter this. So the drawing, okay, is 1 inch. 1 inch in the drawing is 15 feet in actual life. Now, see how these are different? We have to make them the same. So let's leave the 1 inch and let's take our calculator and find out how many inches is 15 feet. So let me bring this in. So to do that, I'm just going to take 15 and I'm going to multiply by 12 to give me 180 inches. Now that you have both the same units, these units cancel out. So you're left with 1 and 1 over 180. So this is our scale factor. That's really small scale factor. That's because the drawing is a lot smaller than the actual court. All right, so let's practice this again. Here we have a diagram that shows, represents a garden. The scale is 1 centimeter for every 20 meters. Each square is 1 by 1. So find the actual length and width of the garden based on the drawing. So what is the scale? Well, they told us the scale is 1 centimeter is equal to 20 meters. They tell us that. What is the scale factor? So K is equal to y over x. That's our scale factor. We're going to do drawing over actual, just to remind ourselves. And we're going to use the scale that we just came up with. So 1 centimeter is in the drawing. 20 meters is in the actual garden. Now, we can't do anything because they are not the same units. So we're going to change 20 meters to centimeters. So if I go back to King Henry, okay, I'm just going to write this on my paper. King Henry doesn't usually drink chocolate milk. That's the saying that I like to use to help me remember the order of that. Once again, that was King Henry doesn't usually drink chocolate milk. Anyways, so we're going from meters, which is the U, to centimeters. So we're going 2 spots to the right. So if I do that, I get 2,000 centimeters. So let's change the 20 meters to 2,000 centimeters. Now they're the same, so the centimeters can cancel out, and you're left with 1 over 2,000. Now that's also a very small scale factor, and that's because the garden is a lot smaller than the actual size of the garden. All right, next page. All right, let's keep practicing this. Here's a graphic designer that is creating an advertisement for a tablet. She needs to enlarge it. So the picture here, so that 0.25 inches on the scale corresponds to 1 inch in actual advertisement. So the scale is what we just were given. So 0.25 inches is equal to 1 inch in actual life. Now, just like we did the other day, we're going to divide this by 0.25. So 1 inch is equal to, so 1 divided by 0.25 gives us 4. So 1 inch on the drawing will give us 4 inches in actual advertisement. So this is our scale. So let's find our scale factor. Remember, that's the unit rate, K equals y over x. So my y is my drawing. Yes, I have to write this every single time. My x is my actual. So in the drawing, it's 1 inch. The actual is 4 inches. This is in the same units, so we can cancel those out. So that means that our scale factor is 1/4, which means the drawing will be 1/4 of the size of the actual tablet. All right, I'd like you to try the next 2 examples on your own. Hit pause, do them, and then when you're done, go ahead and make sure you have the correct answers on your paper. All right, so they give us the scale. It's saying to find the scale factor, K equals y over x. So that is the drawing over the actual. So we have 1 inch is in the drawing, 6 feet is the actual. We cannot have this different units, so I'm going to change everything to inches. So 6 times 12 is 72. Inches cancel out, and my scale factor is 1 over 72. All right, scale factor, here's my scale. So we're asked to find the scale factor, K equals y over x. So we're going to do drawing over actual. So 1 inch in the drawing is 2 feet in the actual car. So let's change them to inches again. 2 feet times 12 is 24 inches. Both our inches cancel out. So the scale factor is 1 over 24. All right, I'd like you to keep practicing finding the scale and scale factor on your problem set. We will go over this in class tomorrow.